the processors dictate the whole system, right? If you can't process, meat animals, you're in trouble. You either have to try to get them off of a weight gaining regime in the short term to extend their live animal status before you can process them, or you have to destroy the animal.
Hi, welcome to the Beef Podcast. Happy to have you with us. I'm Brad White, one of the hosts, and as this podcast is brought to you, we'd like to have a variety of topics and guests that will be applicable to you and your business. If you ever have topic ideas, you can submit them online, either by following the Beef Podcast or sending an email. So we're happy today to have Dr. Randall Phebus with us, who is a professor of food safety at Kansas State University's Food Science Institute and a member of the Animal Science and Industry Department. And he's going to share a lot of his interesting work with us. Good afternoon, Randy.
Hello, how you doing?
Good. We're happy to have you with us. And we've got some great topics to get into today, but I may start just by having you give an introduction of yourself. Tell us a little bit about you.
Okay, well, I've been at Kansas State University. I'm now in my 32nd year. So I'm a full-fledged academic by now, I guess. And I've always focused on food microbiology, food safety, and do a lot of research, not with just meat and poultry, but with virtually every food commodity, including pet foods. So if it's Salmonella, E. coli, or Listeria, I'm probably doing some research with it. I am also a research fellow at our K-State Biosecurity Research Institute, which kind of gives us some pretty unique opportunities to do large-scale, pretty nasty type research with agents that most organizations can't work with. We call them select agents. In addition to research, I have a teaching appointment and teach food science to undergrad and graduate students. So that's me in a nutshell. I hail from the wonderful state of Tennessee, which is where I am today, experiencing Christmas here with my family. But I really enjoy my time at Kansas State University.
Data shows most cattle don't get the vitamin D they need, especially in winter months. High D from DSM Firmenich can ensure your cattle get the recommended vitamin D level to support bone strength, help immunity, and improve performance. Visit dsm.com/HY-D to learn more.
That's excellent. And I think it's one of the things as we get into some of the different topics, you've got a variety of research interests. So food safety, but that covers a big spectrum. How did you get into food science?
Well, that's a very interesting story that we probably don't have enough time to go into. Actually, my parents owned a grocery store my entire life, and so from the consumer side, I was somewhat exposed to meat cutting and consumer goods my entire life. But then I went to the University of Tennessee studying animal science and pre-vet, and finished my BS degree in animal science there. And just by chance one day in the adjoining building in the men's bathroom, I ran into a really key meat science figure at K-State, Dr. James Riemann, who was a K-State grad, by the way. And he talked me into going to graduate school in food science. And once I was in food science, I took the pathway toward food microbiology and food safety, just because I have always been intrigued with public health and the microscopic life and its contributions to spoilage and public health and animal health and that sort of thing. So it just kind of fit all the bills for me.
So that's an interesting story, and we often, in retrospect, it's easy to sort some of the details out, but at the time, you don't realize some of those chance encounters and the role it plays in your life as you go to the next step.
I'm probably one of the few people that made a career decision in the men's bathroom, but I did. That's an honest story.
So the moral of the story is always go to the bathroom. You should do that at least once a day.
Yeah, it was very, very interesting for sure. But it was a good choice.
Excellent.
Very good choice.
You mentioned public health, public safety. You've been doing some research lately, and one of the biggest public health issues we faced in the last several years was COVID. And I know you did some research related to COVID in the processing plants. Tell us a little bit about what were the objectives of that research, and what did you learn?
Well, if you think back to 2020 early, we knew nothing about this virus, basically, in any kind of setting, basically. And everybody was pretty much in panic mode, including the government and the World Health Organization. And so there just wasn't much information that you could really operate society on or operate a business on. People were getting sick. And so, in the meat industry, particularly here in Kansas, we took it really hard. We had plants shut down for extended periods of time. We had people getting really sick and dying in those plants. Our supply chains were a mess, including at the producer level, people didn't have places to go with their hogs and cattle, and when we shut down plants, and so it was just a real big mess. And at K-State, you're in the vet school, but I'm in the Department of Animal Science, Food Science, but I'm not a virologist by training. I'm a microbiologist, but we have tremendous virologists in our K-State vet school. And when USDA realized that they had to address COVID in the food industry, not just meat, but the food industry in total, they opened up basically an emergency grant program, and we gained one of the emergency grants. It was $1 million for 3 years to try to figure out how this virus persists in the meat processing environment, how the things that the industry was trying to do to mitigate that risk were working, and then trying to kind of give guidance to the government and to the processors on what was effective and what is not effective. And so we have now just barely finished collecting data. We're doing all the report writing and things now, but it's just like what you see in schools and all aspects now. We know a lot more about COVID today than we did back in 2019, 2020. And probably some of the things that we tried to do didn't help, and who knows, maybe even increased your risk. So now, hopefully, as we've kind of mitigated the emergency factor of the COVID outbreak, cooler, more logical heads can prevail, and we can get ready for whenever we have to face another threat like this.
So as you went through the process, there's a couple things that are interesting there. One is relative to the specifics of COVID, but two is we really realized the importance of those meat processing facilities as a part of the industry.
Oh, yeah.
Right? Sometimes they seem like, we know they're important, but boy, that has dramatically changed how we see flow and supply chain management. Yeah. Can you speak to that a little bit about what you've learned through that process that might be helpful?
Yeah, a couple of really important things, in my opinion. First is, the processors dictate the whole system, right? If you can't process, meat animals, you're in trouble. You either have to try to get them off of a weight gaining regime in the short term to extend their live animal status before you can process them, or you have to destroy the animals because, or do some sort of, byproduct rendering or something out of it. It's really just devastating to producers and to processors and to consumers when this sort of thing at the scale that COVID brought about rears its ugly head. But the other thing that's, especially here in Kansas, that's more immediate is that in the communities where these, particularly the large harvest, slaughter facilities, processing facilities, they are such a big piece of that community and that region that if you've got people sick, or if they can't go to work, or if the plant's shut down, then your whole economy, your whole way of life in those areas is really greatly altered, if not at a standstill. One of the things that we saw in the communities where the large packing plants was they had about a 10-time higher rate of COVID infections and deaths compared to places in the country that didn't have those production facilities, those processing facilities. So it was all, a really complex, interrelated thing. And when you think about the population that's working in the plants, the cultural aspects of it, they're very family oriented. Oftentimes, this immigrant workforce that lives in, group settings, large family settings. So, if you're carpooling to the plant and things like that, there's a lot of opportunity, close natured aspects that promote the spread of a respiratory virus. And so that's part of what we tried to do, is not only talk about the science of, how COVID persists in the processing plant and where it persists and that sort of thing, but also kind of provide some guidance on, separation of people, even when they're not in the meat packing plants and things like that. So it had a lot of aspects to it. And, land grant university, you always focus a lot on outreach and extension. And so we partnered with the University of Georgia. Two of my former students are down there, and they have a really rich history and extension with the meat and poultry industry. So they helped a lot spread the word of what we're finding.
And interesting that it sounds like what you're saying, if I'm paraphrasing, is it's not just if the virus is there, but it's the type and amount of exposures. And those can occur in the workplace, out of the workplace. But
Exactly.
It's an effect that is based on multiple factors, not just do we have a virus.
Oh, yeah. As I mentioned, we've come in this very short time, not just our group, but people all over the world have come to know a lot more about SARS-CoV-2 virus. And basically, the environment plays a huge factor in how stable the infectious nature of the virus is. If you think about all of the separation, keeping 6 feet separation, you remember the lines in Walmart and all that kind of stuff. Well, it turns out, that maybe that's not adequate. We're finding in some of the meat processing facilities that the virus can go about 30 feet without much negative attrition. And so, it really comes down to the humidity and the temperature of the environment that it's in, the surfaces that are involved. In the meat processing facilities, we've got a lot of stainless steel and a lot of nylon and plastic polytop type cutting surfaces and concrete and things like that. Well, we now know that the virus has quite a different persistence on these different types of materials, and especially based on temperature and humidity in the room that we're talking about. And then greatly impacting that is airflows, air currents and whatnot. So back when all of this started, we had a lot of things that we worried about. For instance, you're in the veterinary side of things. We talk about fomites a lot, right? So surfaces where the virus could be, toilet tops, door handles, meat cutting knives and tables and stuff, and their contribution. Well, we worried about that a lot at the initiation of this, and in schools and stuff like that too. But now it's very clear that the respiratory aspect, bioaerosols and what you breathe in, is where the real risk is. And so that's kind of where, the industry has to focus now. And especially now with the industry, there's a huge percentage of vaccinated workers now compared to back then. And so the fire is out a bit. We don't want to completely say COVID is not an issue, but we're in a much better position now than we were back in 2020 and 2021.
Yeah. So three years ago, difference in knowledge, difference in what was going on and how we were responding to it. I guess I'd be curious and maybe, and I'll say it this way, moving away from COVID alone, what are maybe a couple lessons that you see learned in the meatpacking industry from that event that will be helpful next time we have a disruption in the supply chain?
Oh man, I could go on and on about those sorts of things, but the first one that immediately comes to mind is we have some extremely intelligent people in our food processing industry. Back when I started in 1992, working with industry compared to what it is today, the level of scientific knowledge in these large processing facilities is off the charts, probably stronger than what we have at the university in some cases. And so they make some really good risk-based decisions. But unless you have, a means of collecting data, not just from your operations, but from the industry as a whole, and sharing, what are you doing in your plant versus what the next plant's doing, then you're going to be much slower to make progress. And I think, even way before COVID, back when we started talking about controlling E. coli 0157 in the beef industry back in the mid 1990s, the industry came out and said, we are going to work together on this public health problem, which means we're going to share data, we're going to share technologies, it's not going to be proprietary. And, some people are a little skeptical on industry and whatnot. It's so competitive, but I have witnessed that they do that on the food safety effort. Now, if you've got a product development or something that they're going to make money on over the other, then yeah, that's competitive. But food safety is not competitive. Well, COVID, and if the next thing we have to deal with is African swine fever or foot and mouth, whatever it is, the industry is going to come together and work with people like me and with themselves to address it as fast as it can be addressed.
Yeah, that's a great take home, because a lot of times at the university, part of the job is do the research and then part of the job is share the research. In private companies, it's do the research and don't share the research, right? In most, when it's not related to industry issues, when it's related to competitive advantages, and this is a different scenario. So one of the things that you're saying is highlight that mechanism for sharing and deciding which goes into which area.
Absolutely. And the meat industry, when you start talking to the people who kind of direct the food safety and operations management, when you're looking at the director and vice president level people, it's not that big of an industry. I know most of the people, as a matter of fact. And, the night that we decided that we were going to write this grant to USDA to pursue this COVID funding, the first thing that I did, and probably the most important aspect of us getting this grant, was I solicited a very high profile, powerful industry guidance board who, they were with us from writing the grant to right now putting out, information and determining what the data means. So they were a true partner. And it's not just the meat processors. We brought in technology providers, sanitizer companies, and air sampling companies and stuff that have much more expertise and better equipment than we have. And they were here suiting up and going to work with me in the morning, So that's kind of where you make the fastest, most, inspiring discoveries, is when you pull these groups of people together to work as a team.
Yeah, that's right. And that's what makes it fun. And I ask you about learnings for the meat processing industry. If we turn our gaze the other direction and say, okay, what did you learn from this on the meat processing side that you would pass along to producers in the supply chain? So if we're thinking on the beef side, even all the way back to the cow-calf side, is there anything there that you would say, this is something to be aware of?
Well, if we are specifically talking about the COVID project, the production people had a lot of issues going on too, milking parlors and, sale barns and all of those things. I mean, you really think about a human respiratory disease, especially one as infectious as coronavirus is, then you've got a lot to deal with. So it didn't really matter if we were in a school, a church, or a livestock barn, or a processing plant. When you start understanding bioaerosols, when you think about air currents and managing, air turnover in closed spaces, the big controversy is mask. And, I've got my own opinion that I'll leave unannounced today, but you learn so much in all of these studies that can be applied across the board in a lot of cases. And, In the meat industry, we one of the first things that they did in the processing side was put up plexiglass dividers between line workers because these people are 2 to 3 feet spaced and they stand there for 8 hours a day or more side by side. So if you've got an infected worker, you're going to get a huge amount of exposure. Well, I worked with the big companies like Tyson and National Beef and Cargill and these in this project to determine how effective are those dividers and including lunch tables and stuff. Well, immediately you can apply that to libraries and schools and hospitals and Walmart checkout centers and everything else. And the results that we saw was some very interesting engineering studies, airflow and laser light scattering and things that we did on this project. You see a lot of things that kind of defy logic as far as the way the air is moving and thermal currents and things like that. So, that was, I guess, the most exciting and I guess what I learned the most from this project is working with these engineers on things that I had never really put a lot of effort into professionally. But they became, probably the foundation of the research that we were doing. It's controlling air, since these air droplets are in the air and move over great distances.
So and maybe you don't have the data analyzed yet, but were the plexiglass dividers, was that helpful, not helpful?
Probably not as helpful as you would think, but I'll give you an example. If you're sitting at a cafeteria table, people on one side and people on the other, and you're trying to talk to each other across the table, and you've got a plexiglass divider between you, a clear one, so you can see them. You would think that would kind of solve the problem of aerosols. But basically what we saw with some of these studies was that you kind of get a thermal current from the aerosol. It starts kind of circulating like a smoke screen, and it goes up over it, and then it kind of drifts its way right back into the face of the people on the other side. And so, it doesn't take much control of air, as that's happening, to prevent it, directional airflow. So you got to know and characterize the problem before you can fix it. It's what you learn. Yeah.
So interesting work there, and not what you expected to do, because a lot of your background is on food safety.
Yeah.
So also human focused side, but the food safety, and you mentioned before, you've done a fair bit with E. coli, you've done some other work.
Yeah.
Tell us a little bit about your food safety work.
Yeah, my main areas of food safety work, I work in a lot of different areas, and I consult and troubleshoot with the industry a lot, both on food spoilage and food safety. But the primary area that I have concentrated my research program over the 3 decades is in 2 areas. The first one is what we call process and technology validation. So I do these very large inoculated studies. So I may put on a full side of beef, I may put 1 million E. coli per square centimeter on that carcass. And then I run it through commercial grade type, what we call interventions. It could be carcass washes, it could be, lighting of dip pulse field light or whatever it is, but carcass level interventions that the industry is interested in. And so I see how much I can kill in log cycles. So, I'm looking at percentage kill. And then what I do in those inoculated studies, which happen mostly over there at the Biosecurity Research Institute that I mentioned, because we can do large scale commercial grade type studies. What I find out, then I send that information to the food processing companies for them to make decisions on which intervention fits into their process the best, which can they afford, which addresses in their hands. There's not really one size fits all in any plant with any technology, and especially when you consider economics. You got rich companies and not so rich companies. But if they know that, technology A versus technology D give you similar results, and, you can apply them without, negative impact on quality, then that gives the companies tools to make good decisions as companies. So that's kind of where I guess, made a name for myself over the years, is conducting these large intervention studies. And then I help the companies, even when they make that decision, verify the operation of that equipment in their own hands and their own companies. Because what I do, at K-State might turn out to be a little bit different result-wise as in their hands, or it might need to be fine-tuned. So that's kind of the way I work. The other big area that I've worked in all these years is in pathogen detection, and how long pathogens survive and how well they attach to different meat or food surfaces or processing equipment surfaces, biofilms and things like that. And then the sanitation programs that have to happen to handle that sort of thing. So I guess, 90% of the work I do, Brad, would be considered applied research, but I work with a lot of fundamental scientists that are trying to figure out mechanisms and, at that level. But I like to take that research and put it to use in big ways.
Yeah, I think that, and Randy, that's, I think, a good way to describe how do I evaluate, does it work or not? And then that all fits into, as you described, a cost-benefit equation, right?
Oh, yeah.
What are the costs, what goes through, what are the benefits, both system cost and costs of failure. So similar to anything else, you've got to know all the pieces of the puzzle, accuracy of the system and everything else put together.
There's some things that are kind of secondary considerations, but they almost become primary considerations, particularly as we look at things today. And I'll give you a perfect example. In these large meat processing companies, even medium and small ones, but especially large ones, we use a tremendous amount of water, both as carcass and subprimal washes. It's almost like a car wash that we put all of these carcasses through. And we're applying lactic acid and peracetic acid and bromous acid and all of these things as our primary antimicrobial technology. Well, here in the Midwest, we're starting to realize how precious water is and trying to conserve that water. And so you've got all of the water reuse from those carcass washes. But better yet, if we could develop technologies that are just as effective, but use, a percentage, if not a great percentage, less water, then that would give companies, a really big economic incentive to use that technology. So I've been some of the last work that I've done was comparing all of these different carcass washes. Some of them are high volume and some of them are low volume, and giving them actual microbial kill numbers that they can make those decisions. And at the BRI, I've also got an electrostatic spray cabinet that you can, I can cover a carcass with, some of these really like 5th generation antimicrobials that are expensive. I can cover that carcass top to bottom, inside and out, with 5 milliliters of that compound, whereas it might take 100 gallons of hot water or lactic acid. So there's a lot of innovation, and I think the future is going to be in that direction, just because we are having to, look at environmental sustainability so tight today.
Yeah, absolutely. And I think that's pretty interesting to see how some of those things develop and evolve over time. Because as you talked about through your career, what have been some of the biggest innovations you've seen in food safety thus far? Because it's kind of been an arc. You mentioned we didn't do a lot of looking for E. coli in the 90s.
No, well, there's been a lot of innovations, both on the pathogen detection side and then on the pathogen control intervention side. So on the pathogen detection side, man, when I first came to K-State in 1992, 1993 and 94 is when the Jack in the Box E. coli outbreak was really hitting hard in the Pacific Northwest. And, we just barely discovered Shiga-toxigenic E. coli at that point and didn't know hardly anything about it. And so one of the first projects that I did was working with Cargill and an equipment manufacturer called Frigoscandia, and we developed the steam pasteurization process for beef carcasses. So that process was a total new innovation, and it was like a big cabinet that moving line carcasses passed through, And we had a patented way of applying steam inside and out to the full carcass, because you got to do it in a manner that the steam condenses on the surface to become antimicrobial. If you don't have a little bit of a pressurization in that chamber, it won't condense. So to do that on a moving line was very difficult, but we were able to do it. And Cargill and Tyson, in particular, ended up fitting all of their plants during that era with these steam pasteurization systems. At that time, they were over $1 million per system that Frigoscandia installed. And, that kind of led, even if companies didn't install that system, it kind of forced them to put in other interventions and validate other interventions, like hot water would be an example, to show that they were almost as effective as steam pasteurization, or the government, and the buyers wouldn't continue to buy from them. So the other thing on the detection side, the biggest invention has been polymerase chain reaction technology. And now we've talked about whole genome sequencing, because now we can track contamination back to the live animal, to the region, to the drain that the contaminants are in. If you've got contaminated product on the market, it doesn't matter if it's meat or flour or whatever, we're gonna track you down. It's going to come back to you. So companies are really adamant about knowing and getting rid of food safety issues now.
Yeah, and I think that's an important part as you think about how regulations tie in, but it's also the consumers, right? I mean, so it's not just regulations that we're doing those, it's to protect those consumers. And I think that affects all of us, even as we go back to the live animal, trying to figure out, and you've done some of that research, especially with the E. coli, looking at what do we see in the plant? How does that go back to the live animal management-wise? Because E. coli can be really challenging because we don't see sickness in cattle.
Exactly. Even the ones, we call them the big seven, Shiga-toxigenic E. coli, they're the ones that are regulated. They cause severe human illness, but they don't cause any illness in cattle or deer or whatever. And so it poses a very significant challenge. The other thing with these Shiga-toxigenic E. coli is typically they require a very low dose to cause that illness in humans. And so, I guess this is as simple as you can make it, but there's a lot of truth to this. The more you carry in of a pathogen, the more you carry in to a meat processing facility, either on the hide or in the GI tract or whatever, and also the more number of animals that are carrying that contamination, the harder it is to control it using the interventions that I validate. And so, the rule of thumb is try to eliminate or reduce as much in the live animal as possible so that you don't overwhelm your processing interventions. And, I think that we've got mountains of data by this time that proves that to be a true story. Now, you never want to get too comfortable with things, though, Brad, because, now we know that salmonella, which is, the big target in meat and poultry and eggs and almost every food group now, the government is refocusing on salmonella. And with salmonella, the animals can actually, you can do perfect in terms of dressing and dehydrating or whatever, but pigs and cattle can carry it in the lymph nodes. And so you don't get rid of it with your carcass washing and all of that. So that's kind of the issue that we're facing right now, is what is the real impact of animals carrying salmonella in their lymph system, and then how do we control that during meat processing? Because you can cut out the lymph nodes but it's a massive hassle and very difficult process when you're on a commercial setting.
Well, and that's the other thing you mentioned with any of these interventions, and you touched on it a little bit, but they have to go in at processing speed.
Yeah.
You can't have something that takes a long time, even if it's really effective, because then we're not able to process the animals at the rate we need to. But there's a balance, because it has to be long enough to be effective,
right?
But which leads to new innovation. So it's a good job for you, because it sounds like we're not going to get rid of all the challenges, or we haven't yet thus far.
Well, I always tell everybody, and I've been doing this for 40 years now, if you go back to my grad school days, is it is a zero-sum game to try to come out and say that you're going to eliminate risk. I don't care what kind of risk you're talking about. There's going to be some level of risk, and it's always going to be there. You just have to, first of all, try to reduce it as much as possible. The first thing you got to do is understand the risk. Understand what impacts it versus what, is going to spread whatever, or, so it's, I could be working another 100 years and would never generate all the answers to E. coli and salmonella, right? But we can continually understand and reduce the risk so that it becomes more and more, or I should say less and less impactful on public health. That's the goal. And, salmonella is the new, shining star because we've done a good job with E. coli. If you look at numbers, especially in beef, we've really taken it to a very low level. But salmonella, we haven't made much progress in any of the food groups in the last 20 years. We're basically at the same level we were. So government realizes that, CDC realizes that, and in the Healthy People 2030 documents, it's very clear what they're going to concentrate on, and that being salmonella.
Yeah, it'll be interesting to see what you guys come up with in that area, and it's been very interesting to visit with you today.
It's time for our famous three. We have a time and labor-saving product for you. Beef and Dairy Agri-Slat by Healthy Farms is your solution. No more lugging jugs around the barn every month. With Beef and Dairy Agri-Slat, you simply drop the slat through the floor twice a year, and it works to break down solids, reduces crusting and forming. To learn more, visit myhealthyfarms.com.
But before we leave, Randy, I've got a couple questions for you that are maybe a little bit different, not on the food science side, but they're about you. And a lot of our listeners are wanting to be more and more successful in the industry. And first question is, what is your favorite beef-related book or resource?
Well, that we're in the times now, everything's online, right? And so I like to keep up with what's really going on in the industry, because that dictates what my next targets are going to be. So there's two publications that I pay a tremendous amount of attention to, all online. One is Drovers, the magazine Drovers, and the other is Meat and Poultry, which is, also an industry trade. So those are really important sources for me. And the other would be things coming out of BIFSCO, we call it, which is the Beef Industry Food Safety Council. They do so much, and the people who put those guidance documents together are those vice president, director level people that do it every day and know the real issues. So, if I'm going to do things in an applied research manner, I've got to know what the industry knows. And that's where other than my direct communications with them, that's where I get a bunch of my stuff.
Yeah. So keeping up kind of across the board on the big issues.
Yeah.
What about outside of ag? What's your favorite book or resource outside of ag?
Well, you're going to kind of catch the nerd in me, I guess, but I deal with ag and food, but I have the most interest in public health. That's kind of my area. So this morning I was reading new publications about Alzheimer's disease and things like that, because you never know where the crossover to your discipline is going to be. And so, I always laugh because if you look at what happens in the area of food and particularly food safety, you can always look 2 years previous at what was going on in medical microbiology. And then 2 years later, we're doing it in food. So we've got that delay, So I always try to stay abreast and attuned to what's going on in the public health medical sector. And now, just because everything is so technology driven, I'm even reading engineering magazines and stuff to, try cold plasma and pulse light and all of these things, deep UV light and things. They've got food applications. It's just who's going to take them and develop them. Right now, I'm doing a project on nanobubbles. And, we could spend a day talking about nanobubbles, which was used in sludge processing and waste, municipal waste. Well, they got some great applications in food science. And so that's what keeps me young.
That's right. Well, that's the curiosity is invaluable, and
Yeah.
especially if you look at it and think, well, this could help me. I'm reading outside of my discipline, but this could help me.
Yeah.
I love those answers.
Yeah.
If we were talking to a beef professional that's early in their career, and we wanted to tell them, okay, this is what sets apart a successful beef professional from one that's maybe not as successful, what one or two traits would you tell
Oh,
them?
yeah. This is probably the most important thing, particularly in my career as a professor, is developing the next generation of food science and food safety professionals. That is item number one on my agenda at this point in time. And I always tell my students that it all comes from the curiosity factor. You've got to want to know new things, and you can't passively do it. You've got to aggressively seek out that knowledge. It doesn't matter if it's going and talking to somebody over, in another discipline over coffee, or if it's going to an annual meeting or something and straying outside of your comfort zone to talk to people doing new things. And so, I try to teach that in my class, but I really try to teach it to my own graduate students and the other graduate students at K-State. And always, the most important thing is to get them in the real life settings, get them in feed yards and get them in, processing facilities, because you can teach all you want to out of a book. If you can't really see what's happening and kind of feel it, it ain't going to ever really register with you, in my opinion.
No, I think you're right. And maintaining, growing that curiosity is a great way to go to the next step. So we've enjoyed having Dr. Randy Phebus on today's show, and thanks for making the time. And if you have further topics or people that you'd like us to talk about, you can reach out to us and give us some ideas. Thanks, Randy.
Thank you. Appreciate it.